recording. All right, so today's lesson, actually the whole week we've been learning about the lines. We've been learning about, we started off with learning about how to make a table of values. And then we learned about parallel and perpendicular lines, horizontal, vertical lines. That was last day's work. And now we're going to talk about what happens when there are two lines that meet each other. And that is known as intersecting lines. So if you take a look at the little diagram here, it's kind of like a creative way to show two parallel lines are lines that never ever cross or meet. Two perpendicular lines are lines that meet at a 90-degree angle. And two intersecting lines are basically lines that cross each other at a point at any angle, it doesn't matter. And the area where they're going to cross each other, that's the part that we're most interested in. Okay, that's what we're going to look at. That's my cat. I don't know if you can hear her. So like I said, this lesson is posted on Brightspace if you would like the graphs and all that stuff to be there on the sheet already. So feel free to print it off. The formatting may be off a little bit, but that's okay. It still has the same content. Snake, it looks like an alien. Okay, you guys entertain yourselves. Graph the lines y is equal to 2x minus 2 and y is equal to x plus 1 on the same graph and find the point of intersection. Okay, so we're going to go ahead and graph these two lines using y is equal to mx plus b. So this is a good time for us to review that. I will review it with you guys. Okay, so let's look at the first line. It's y is equal to 2x minus 2. In this question, the slope is going to be 2 over 1. And the y-intercept is going to be negative 2. So I'm just going to write slope is going to be 2 over 1, or the other way to think about it is negative 2 over negative 1. And the y-intercept is going to be negative 2. Another way to think about this is 0, negative 2. So hopefully you guys remember doing all of this before our break. Let's go ahead and try to graph this line. So we're going to begin wherever the y-intercept is negative 2. And then you're going to use your slope to figure out what's happening. So remember the rules. If the number at the top is positive, it's going to be up 2 and 1 to the right, down 2 and 1 to the left. You can just say 2. The reason why I write 2 over 1 is because it tells me like which direction I'm going. And so that I feel really helps. But yeah, you could just write slope is equal to 2 and that is perfect as well. So I'm going to go up 2, 1 to the right, up 2, 1 to the right. And I'm just going to keep going with this pattern until I've graphed it. Down 2, 1 to the left, down 2, 1 to the left, down 2, 1 to the left, down 2, 1 to the left. And then I'm going to connect all of my points. Oh my gosh, look at that perfect line. That's rare. Okay, we're going to do the exact same thing now with the other equation, which is y is equal to x plus 1. What do you guys think is the slope in this question? Good, thanks, Aberami. 1. And what do you think is the y-intercept in this question? Also 1, yeah. So I'm going to write down the slope is going to be 1 over 1, or another way to write it is negative 1 over negative 1. And the y-intercept is going to be just a positive 1. And if I want to write that down as a coordinate, it's going to be 0, 1. So what does this mean? This means we start our line at wherever y is equal to 1, and we're just going up 1, 1 to the right, up 1, 1 to the right, up 1, 1 to the right, all the way till the end of the graph, or down 1, 1 to the left, down 1, 1 to the left, all the way to the end of the graph. All right, you should label your graphs. So I forgot to do that before. This is going to be y is equal to x plus 1. And this graph is going to be y. I don't like that it's so squished. I'm going to write it here. Y is equal to 2x minus 2. I'm going to pause here. So if you're still graphing, you can catch up. Now that we've graphed the lines, it is very clear to see where the two lines intersect. And for all the questions we're going to do, I'm going to only be giving you points that intersect at a place where you can see it very clearly. Like it shouldn't be any fractions or anything like that. So when it says find the point of intersection, I circled it. I just need to figure out what that point is. So when I look at it, it looks like it's 3, 4. And the way I'm going to write that is, I guess our short form of point of intersection is just POI. That's what point of intersection stands for. So I'm going to say, therefore, the point of intersection is at 3, 4. And then that's our final answer. So I think it's pretty straightforward. You basically just graph whatever lines they give you, and then you step back, take a look at it and see where they intersect, and then that would be your final answer. All right, let's try the next one. So we think our solution, the point where these lines intersect is 3, 4. Check. To verify the solution, substitute the coordinates into both equations and use the left side, right side method. Okay, so we think the point of intersection is 3, 4. The only way to make sure of that is we're going to put this point into both of the equations. And if the point of intersection is 3, 4, then the left side should equal the right side. All right, so let's try it. For the first equation, the left side of the equation is just y. So I'm going to write that down on the left side over here. I'm going to write down this is y. And for this one, the right side of the equation, it's 2x minus 2. And now I'm going to be using the point that we got up here. So maybe I'll just write it on over here. We're checking using the point 3, 4. 3 is your x and 4 is your y. Okay, so my y is just a 4. And then for this side, it's going to be 2 times 3 minus 2, which is 6 minus 2, which is a 4. So this is great. We can say, therefore, left side equals right side. And if you'll recall, we learned how to check our solution when we were doing equations. So we have practiced doing this before. You may just need to jog your memory by looking at some of those old handouts. Okay, so this equation works out. It seems like 3, 4 is a solution for this one. How about the one right beside it? So let's try that one. We're gonna the left side of this equation over here is y, and the right side of this equation is just x plus 1. And I'm still going to use the point 3, 4 to solve this. Okay, so my left side is y, which is just going to be equal to 4. And this side is going to be 3 plus 1, which is also 4. And so this is also left side equals right side. So when you get a solution like this, where you check your answer 3, 4 with both of the equations and everything is left side equals right side, that means our answer is correct. Those two lines intersect at 3, 4. Question number 2. Carson is considering joining a ski club for the winter season. Very relevant to our weather right now. He is considering the following 2 options. So you have the standard rate, which is $50 per day and no registration fee. Or you have the frequent extremist rate, which is $40 per day and a $100 registration fee. Okay, so registration fee is kind of like if you use a particular skiing club, you have to pay the registration fee to use it for the whole year, and then you also have to pay a daily amount. So there are 2 different scenarios, and we're trying to figure out which one is the better one for Carson. Write an equation that relates the total cost C in dollars and the number of days N that who's Mike? that Carson goes skiing if he chooses the standard rate option. Sorry, I don't know why I changed that to Mike when it clearly should be Carson. He's having an identity crisis. Just so we don't confuse anyone, clearly Carson is actually Mike. Okay, so I'll pause here. Go ahead and try and figure out what a possible equation might be for this question. Okay, so you got it right. We're going to write that down. So the cost in dollars is going to be, for the standard rate, every day costs $50. So it's going to be 50 times n and nothing else. And this makes sense, right? If Mike goes skiing for a day, it'll be 50 times 1. If Mike goes skiing for 2 days, it's going to be 50 times 2, et cetera, et cetera. Write an equation that relates the total cost C in dollars and the number of days, and that Mike goes skiing if he chooses the frequent extremist option. Okay, now this equation is going to look a little different. It's going to be cost is equal to, per day, Mike is going to be paying 40 times n, but then there's also $100 registration fee. So it doesn't matter how many days he goes, he's still going to have to pay that $100 registration fee, right? Okay, so that example is going to be 40n plus 100. Question C says graph both of the lines on the same graph. Okay, so go ahead and try this. It's the same way we did it before. I'll write both the equations over here. This one is going to be 50n, and this one is going to be 40n plus 100. Now, if you would like, you could make a table of values for this because it's going to be a little bit harder to figure out what a slope of 50 is. Actually, for the first part, it won't be too bad, but for the second part, it might be a little bit trickier. Okay, so I think for this question, I'm going to go ahead and make a table of values and then figure out what's happening with that. Okay, so to make our table of values, I am going to make a line. I'm going to pause so you can't watch me do my table of values. All right, 10 minutes later, I have finally created my lines for the table of values. So for the table of values, I'm going to have C on one side and N on the other. So for this question, we're going to go C, and actually, let's do it the other way around. Let's put N on here and C over here. And I'm just going to put like random days. So we can do 0, and I can do 2, 4, 6, 8, and 10. Why am I picking those? I'm kind of cheating. I can see that that's the scale they went up with here. If you didn't want to use those numbers, you could also just go 0, 1, 2, 3, 4, 5. That's fine as well. But I'll stick with 0, 2, 4, 6, 8, 10. Okay, now I'm going to be putting these numbers into the equation. So 50 times 0 is just 0. 50 times 2 is 100. 50 times 4 is 200. 6 is 300. And then it's 400. And then it's 500. I'm going to go ahead and graph this line. So 2, 100. 4, 200, 6, 300. I think we can all see the trend. 8, 400, and 10, 500. And then you're going to connect all of the dots and join this line together. And I'm also going to label this line. So with the equation, which is C is equal to 50n. I'm going to do the exact same thing now for the other equation. I'm going to call this N, I'm going to call this C. I'll use the same numbers as before. So it's going to be, I'm just going to move this up a little bit so I have more room. It's going to be 0, 2, 4, 6, 8, and 10. And now we're just going to solve the equation. So 40 times 0 is 0, 0 plus 100 is 100. And this makes sense, right? Even if Mike does not go skiing for a single day, he still has to pay the $100 registration fee. Okay, 2 days would be 180. 4 days would be 260. Okay, that's written. 6 days would be 340. 8 days would be 420. And 10 days would be 500. Okay, I'm ready to go ahead and graph this. So you have to be careful. This graph is not going to start at 0, 0. It's going to start at 0, 100. Again, that makes sense. So even if Mike doesn't go with the second option, the frequent extremist option, even if Mike doesn't go skiing a single day, he still has to pay the $100 registration fee. Then we're going to have to estimate where these numbers are going to be. So 2 and 180 will be, I think, approximately there. 4 and 260, I think we'll be right about there. 6 and 340, approximately there. 8 and 420, about there. And then 10 and 500 are going to be there. Even if your points are not as accurate as you want them to be, you should be able to very clearly see where these two lines intersect. Why can't I see where this is going? Oh, because it's lagging on my screen, that's why. Okay, well, you know what? This is close enough. All right, close enough. You guys, what is the point of intersection for these two lines? In fact, even if you didn't look at it on the graph, you can look at it on the table of values and you should be able to see where these two lines clearly intersect. What do you think? Yeah, it's going to be at 10 and 500. And look at the table of values. At 10 and 500 and 10 and 500, you have exactly the same 2 points on both of the lines. And also, if you've drawn your graph accurately, you should be able to see that you have 2 points at 10 and 500. Okay, so I'm going to do a couple of things. Number one, I'm going to label this other line, which I forgot to do. So this is C is equal to 40n plus 100. And then number two, I am going to, for question B, I'm going to write, what is the point of intersection? The point of intersection is going to be 10 comma 500. So what does this number mean? It means for both plans, oh, actually, that's the next question. So what is the cost of both plans at the point of intersection? What does this mean? This means that for both plans, after you have used it for 10 days, you're paying the same amount of money. You're going to be paying $500. But before that, look what happens. So if I were to just draw a couple of lines on here just to help you understand, let's say this is 10 and 500. Before that, which plan is cheaper? It's going to be the first one. I can't remember the name of it. It was the standard rate. So if you're going skiing if Mike is going skiing for fewer than 10 days, it would make sense for him to get the standard rate because the blue line is below the light blue line. And so he's going to be paying less. At 10 days, both of the plans are going to cost the exact same money. So if you're going for exactly 10 days, it doesn't matter which plan you get. You're still paying the same. However, after 10 days of skiing, it makes sense to buy the cheaper one which is going to be the frequent extremist option, because after 10 days, that line is below the dark blue line. And so it's cheaper in that case. So really, what should Mike be doing? He should be first figuring out how often he thinks he's going to be going skiing. If he knows that, then he can do the calculation and figure out what plan he should buy. Okay, so given that information, let's try and answer some of these questions. Question E says, what is the cost of both plans at the point of intersection? So we're going to say the cost for both plans after 10 days of skiing is $500. And hopefully that makes sense to you. Without Saoirse's having problems with her computer. Oh no, I haven't checked my email and I haven't done attendance yet. So that's fine. Just let her know that I'm recording it and I'll mark her present. Okay, look to the right of the point of intersection. Which plan is cheaper? So we were just talking about this right now. And to the right, do they mean to the right? Yeah, I guess they meant to the right. So you're looking at this right here. They're asking you which plan is cheaper. That means which line is below the other one. So to the right, we're going to say if, nope, I don't want that one. If Mike skis for more than 10 days, the frequent, everything's disappearing. No, why is that happening? The frequent extremist plan is cheaper. And then for the next one, it says look to the left of the point of intersection, which plan is cheaper. So now we're looking at this part right here. And that means if Mike skis for fewer than 10 days, then this standard, I always forget the name, what's that? Standard rate is cheaper. So let's write that down as well. I'm running out of blues, you guys. I'm gonna have to go to more colors. Get a nice blue. Okay, let's pick something that's like muddy. Okay, let's do that. So if Mike skis, I think skis only has one I. I think I might have misspelled that. For fewer than 10 days, the standard rate plan is cheaper. Before you guys like tell your English teachers that I suck at spelling, I'm gonna change that real quick. I don't know. Can someone tell me if it's skis or skis with one eye or skis with two eyes? Now the one eye looks off. Okay, we'll look that up later. Question H, if Mike is going to go skiing 11 times this winter, which plan would you recommend? So what do you guys think? Which plan are you recommending if Mike is going skiing for 11 days? So you can look at the graph over here and you can say, okay, well, at 11 days, which is right up here, the line that is less than the other one would be the frequent extremist. Exactly, Aberami. So we're going to suggest that Mike chooses the frequent extremist plan. Yep, good job, Julia. All right, question number 3. I don't know if any of you are Game of Thrones fans, but this question is related to Game of Thrones characters. It says Cersei and her brother Tyrion decide to race home. Cersei is a faster runner than Tyrion, so she gives him a head start. Their distance time graphs are shown below. So let's just try to figure out what's happening here. We have time at the bottom in seconds. We have distance on the y-axis in meters. The title says Cersei and Tyrion's race home. And here is what the graphs look like. So we have Cersei, which I will just use a dashed line for so we can tell the difference. So she begins at 0-0. Tyrion gets a little bit of a head start. Can anyone figure out how much of a head start Tyrion got? They both start at 0, the time 0. But Tyrion, if you have a little sibling, you can be like, okay, you can stand here. How much further ahead was he standing than Cersei? Yeah, Gabriel, you're right, because it starts at 100 meters. So the head start was 100 meters. Then they're racing. And at one point, it seems like until here, it seems over here that Tyrion is faster because his line is above Cersei's. But then over here, she starts to overtake him, and her line is on top of Tyrion's, which means she is now running faster. And so something happens at about 50 seconds where they should be at exactly the same location. So that's kind of how you would analyze this graph. You would see the point of intersection, you would figure out what that means in the context that they've given you. In this case, the point of intersection means that at that time, 50 seconds, they have reached 400 meters. So they're exactly neck and neck, like they're tied. But then after that, you look at what happens after 50 seconds and you notice that Cersei's line is on top of Tyrion's line. And so that means she's going a lot faster. All right, so let's go ahead and answer some questions based on this. How much of a head start did Tyrion get? Gabriel already told us he got 100 meters. How fast did Cersei run? Okay, for that, we have to really look at the equation. So the equation is D is equal to 8T. I'm going to write that down. D is equal to 8T. And remember, what exactly does the 8 represent? It represents the slope. But slope is another name for rate. So it actually tells you how fast she is running just by looking at the number in front of the T. She is running 8, but what does that mean? It means she's running 8 meters per second. So we're going to say, therefore, her rate is 8 meters per second. We'll do the same thing for Tyrion. And so look at his equation. It's D is equal to 6T plus 100. And remember, y is equal to mx plus b. 100 tells you where he starts, but 6 tells you what the rate is, right? The slope or the rate. And so we're going to say, therefore, Tyrion's rate is 6 meters per second. And this makes sense, right? Because in the question, it says Cersei is a faster runner than Tyrion. So it makes sense that her speed is 8 meters per second and Tyrion's is only 6 meters per second. And you can figure that out by the equation. If you wanted, you could also figure out the slope by using the lines. You could pick 2 points and use the equation y2 minus y1 over x2 minus x1, or you could just do rise over run and figure it out that way. But if you have the equation, honestly, that's the easiest part. That's the easiest way. For what length of race will each runner win? For what length of race will they tie? Okay. For what length of race will each runner win? For what length of race? What do they mean by length of race? What did I? Okay. So we're just going to say Tyrion wins from time 0 to time 50 seconds. So I guess I'll write it as follows. from 0 to 50 seconds. And Circe, how do you spell Circe? Circe is going to win from 50 seconds to like forever. So just 50 seconds onwards. And then they're both going to tie at, what did we say? Right at 50 seconds. Now I wrote time because that just made more sense to me. What length of race? You can consider that as time. Explain the significance of the solution, the point of intersection of this linear system. So we kind of just went over that. And we know that that point of intersection just shows where they meet up with each other and they are tied. So we will write that as our response. Okay, so the point of intersection shows where they are tied in the race. Take this out. All right, so we've been working on handout G. You may not be finished, but that's okay. We can do the parts that you haven't finished together. I already wrote the answers to question 1 and 2. It's just the point of intersection. For question 3, I had to rearrange the equation a little bit and get it into y is equal to mx plus b form. So this one was y is equal to x minus 8. I graphed that over here. This one was y is equal to negative a half x plus 1. I graphed that over here. And then the point of intersection was just 6 comma negative 2. The question does say check your in both equations. So you should do that. I'll just set it up for you. Basically, what you do is you're going to be looking at the left side and right side of this equation, the left side and right side of this one, and you're going to be plugging in these numbers into both of them. Okay, so for example, for this first equation, x minus y would be your left side, which would just be 6 minus negative 2, which would be 8. So you would just check all of your solutions that way. And as long as the left side equals right side, then you know you're correct. All right, I wanted to do question 4 in more detail. It's very similar to the ones we did before. It's just more practice. It says the King Athletic Council is planning the athletic awards banquet. They want to have it in a nice banquet hall, but affordability is key. So they have 2 options. Billy's Banquet Bonanza, you have an initial cost of $1,500. So like the school has to pay that regardless of anyone shows up or not. And it's very fancy. It's $100 per plate of food. That's insane. That's like fancy wedding numbers. So I guess this is really like, let's just pretend we're all millionaires. You get unlimited beverages and the music and DJ is included. Then Ria's Regal Reception, you have $500 for the DJ and music, $130 per plate of food, and then you have $20 per person for unlimited beverages. All right, so I guess the key numbers to remember here is for this one, it's $100 per plate of food. So per person, it's going to be $100. And here it's $130 per plate of food, but then also $20 per person for unlimited beverages. So they're kind of 2 costs there. And then the $500 for the DJ and music is sort of like a one-time fee. Write an equation that relates the total cost, C in dollars, and the number of people that attend the banquet at Billy's Banquet Bonanza. So pause. So we determined that, actually Aberami and Erie determined that the first equation is C is equal to 100p plus 1500. For the next one, I would actually have to add the numbers together. So I would end up getting C is equal to, and you guys got it right again. I'm just going to add both of these numbers together. It's going to be 150p because every person who attends is going to get $130 per plate of food plus $20 for a drink. So in total, it's going to be 150p. And then plus our fee, you know, you can think of it sort of as an initial cost, the $500, whether people come to this banquet or not, you're still going to have to pay the $500. Okay, so this is an odd choice of colors, but I'm going to stick to it. Let's graph both of the lines on the same graph. And again, we're going to have to make our table of values. Okay, so actually now, as soon as I said odd choice of colors, I'm like, what was I even thinking? I'm going to move this over here. It's going to be 100p plus 1500. And I'm going to move this over here. It's going to be 150p plus 500. Let's make a table of values. All right, so we've set up our tables. We're going to just go up to 10 people. It's not super realistic, but that's what we're going to go with. So for the first banquet hall, Billy's Banquet Bonanza, if no one shows up, we're still going to be out $1,500. If two people show up, that's 100 times 2, which is 200. That's going to be 1,700. If 4 people show up, it's going to be 1,900. Then it's going to be 2,100, then 2,300, and then this will be 2,500. Okay. And then for the other one, if no one shows up, we're still going to have to pay for that DJ and the music. So it's going to be 5. If 2 people show up, that's going to be 800. If 4 people show up, that's going to be 1,100. This will be 1,400. This will be 1,700. And this should be 2,000. Okay, so I have some numbers. Unfortunately, we did not get a scale for this one. So we're going to have to make our own scale. But that's okay. All right, so the bottom scale is pretty easy for the number of people because I just need to go up by 2. So I'm going to start at 0 people, then 2, then 4, then 6, then 8, and then 10. 2, 4, 6. You know what? I could have possibly skipped 2. Let's see what happens if I skip 2, just so we use most of the graph. So 2, 4, 6, 8, and 10. So that works out nicely. And then we're trying to go all the way up to 2,500. We're going to have to go up by 500s. 1,000, 1,500, 2,000. Let's go up by 3. So 500, 1,000, 1,500, 2,000, and then 2,500. And then my graph, my equation is just going to be cost in dollars versus people. I'm going to go ahead and start graphing. So if nobody shows up, that first banquet hall is quite expensive. We're still going to have to pay $1,500. Then, am I recording? Good. If 2 people show up, we're going to have to pay $1,700. So maybe I shouldn't have gone up by this much because now each one of these squares is basically 166, which is a little bit awkward. Shall we commit to this or should we change it? I think we're going to change it. That's a really awkward scale and it's just going to mess us up. So instead, I think I'm going to just skip a line and go up by 500. This just makes it a little bit easier for me to guess where my numbers would be. So if this is 1,500, then 2 and 1,700 would be like right approximately there. 4 and 1,900 would be there. 6 and 2,100 would be maybe there. 8 and 2,300 would be just above that line. And 10 and 2,500 would be there. Some of my points may be off just because I am estimating, but when you draw your line of best fit, you should be able to go through most of your points. Why is my line starting? All right, so this line is C is equal to 100p over So C is equal to 100p plus 1500. I'm going to do the same for the other one. So this time, this banquet hall starts off a little cheaper. Then we have 2 and 800, which is going to be there. 4 and 1100, which is there. 6 and 1400, which is like approximately there. 8 and 1700, which would be about there. And 10 and 2000, which would be right about there. Now our point of intersection is going to be off this graph, which tells me that I chose a scale that is probably not the best. Okay, now, so for this question, you guys see how it says, what is the point of intersection? My graph doesn't have the point of intersection. Were any of you able to extend it enough to get a point of intersection? I don't see anyone in the chat saying anything useful. Okay, same as you. So you guys are not going to like this, but what we're going to have to do in order for this information to fit into our graph, if we put these numbers closer together, we may be able to get a little bit more success. So we're going to have to redo this, you guys, because now we're committed to this. I'm going to erase this and I'm going to do it again, but this time I'm going to make these numbers closer together and try to see if I can get a point of intersection. Okay, we're a little off schedule, but that's okay. We're almost done. So I changed up the scale at the bottom over here. I made them super squished together because the first time we did it, we realized that the graphs were going way off. So now I just went up by twos and made it super, super, super squished. My green line is this one right here, which is 150p plus 500. And my orange line is right over here, which is 100p plus 1500. Now, it might still not be accurate, but at least I have a point of intersection. So my point of intersection, and like yours might be slightly different, just depending on how you guys drew your scale and stuff. But I'm getting my point of intersection to be approximately, I'm just going to say it meets at that line. I'm going to say it's at 16 and 3000. Super estimate. We could use math and figure it out, but I'm going to eyeball it and look at it, and it looks like it's approximately right over here. What is the cost of both halls at the point of intersection? What does this mean? So basically, if 16 people come to both of these banquet halls, then the cost of renting them is going to be pretty much exactly the same. So if 1600 people, sorry, if 16 people come to, and I can already tell the numbers off, but it's okay. Like I said, we're just estimating. The cost of both of the halls is going to be $3,000. $3,000 if approximately 16 people attend. And all of these are approximations because I don't think our graph is very accurate. Look to the right of the point of intersection, which hall is cheaper. So to the right, we're going to look over here and you look at what line is underneath which one. So the orange line is underneath, and that means that was Billy's Banquet Bonanza. So this means Billy's, this we can say with certainty. So Billy's Banquet Bonanza is cheaper. And look to the left. So on the left, which line is below which one? So the green one is below. That means it's going to be cheaper. And that green line is Ria's Regal Reception. Which hall is the better deal if 50 people are coming? So what do you guys think? If 50 people are attending this banquet hall, which one of these lines or which one of the packages is cheaper? Yeah, 50 means like you're way over here, and that means that this orange line is going to be below the green line, and the orange line refers to Billy's. So Billy's Banquet Bonanza. All right. Hopefully that wasn't too painful. I know there were a couple of mistakes made along the way, but that's okay. I'm going to tell you your homework for this section, you guys, is going to be, we already completed handout G, so we did part of your homework. It's going to be page 441, number 6 to 16.